Welcome everyone to the second Green Building Solutions expert talk, which we are hosting. My name is Dominique Bourret with ÖAD Student Housing based in Vienna, Austria. So we're very happy to welcome today. We have registrations from 33 countries. The last time I checked, 140 people. So very happy to have you here today. We're organizing these side events, online side events for our topics of interest, our partners and everything. So if you would like to organize such an event with us, please get in touch with me directly and we'll be happy to see how we can discuss some interesting topics. Like today, we have circular economy for buildings. So with that, I would like to invite my dear colleague, Barbara, to come on screen and tell us a little bit more about where we are coming from as ÖAD Student Housing and the Green Building Solutions Summer University Program. Thank you very much, and I will see you later. Barbara, floor is yours.
Hello, thank you, Dominic. So a very warm welcome from my side also to all our participants today. My name is Barbara. I'm the organizer of the Green Building Solutions Summer School, and I'm working on the OEAD Student Housing, which is located in Vienna. We are a non-profit organization and a daughter company of the OEAD, who is the exchange company for international students. Our main duty is to accommodate these incoming students in energy-efficient student dorms all over Austria, so in the main cities for studying. And we have right now 8 energy-efficient dorms, which are built in Passive House standard or even better. We are a pioneer in ecological construction. We constructed the first Passive House dorm in 2005 in Vienna. And since then, we only built in Passive House standard or even more. We organized 2 summer schools here in Vienna based on our experience, on the one hand, with ecological building and on the other hand, with alternative economics. So in the Green Building Solutions, we are dealing with sustainable construction and architecture. This means we target architecture students, planning students, ecological engineers, everything that has to deal with the do with the built environment. The Green Building Solutions in general is a 3 weeks program, which is a cooperative project between many different national and international universities. And we are doing this year for the 2nd time online since last year. Since the pandemics, we are hosting it from Vienna and offering it online. In 2019, we had this program in person with 50 students in Vienna. And last year we had nearly 30 participants spread over 20 nations and 9 time zones working together also on a real life design study. Our 2nd summer school is the Alternative Economic and Monetary Systems. It's also a cooperative project between different universities in Austria and worldwide. It's dealing with alternative approaches to our money and financial system, but also the economics that we are having at the moment. And it actually is open to every student that is interested in these topics. Those summer schools take place in July and August. Application is already open. And as you already heard, these expert talks are organized in the frame of this Green Building Solutions Summer School. the idea behind this is to open up these topics to the public audience and to discuss with experts on these urgent topics in green building. Okay, so I will be there this session. Feel free to post any questions and to ask me via email. You find every information on our website, which is sanma-university.net. And I hope you enjoy our second expert talk. With this, I hand over to Christoph. Enjoy the talk. Thank you.
So hello from my side also. I'm really excited to see that many people here for our circular economy in the building sector from waste to wonder session. Just 2 words to me. I'm working as a consultant on circular economy topics, usually with industry, but I'm also very interested in what is going on in the construction sector. Construction and building operations are a huge contributor. First of all, everybody needs housing, and most of us actually do live in houses. But then also, construction and operation of buildings are accountable for roughly 40% of global CO2 emissions and energy consumed, and more or less 50% of global material demand and waste generation. And it's rising. It is projected that building activities globally will put another New York City on the map every month for the next 40 years. So the question is the most sustainable building the building that is never built? Probably this is not the way out. Therefore, a closer look on what we build and how we build it makes sense. What we build today is literally cemented in place, at least most of the time, for the next 50, 60, 70 years or so. It really pays off to think about subsequent use already in the planning phase. Easy to say, a little harder to do. So to shed more light on how to build future-proof buildings, I'm happy we have 2 true experts as guests today, Marloes Fischer and Roland Bechmann. Marloes is president and general manager of Madaster, Switzerland, and she will explain how at Madaster they are working on their vision of a waste-free environment in construction. Roland Bechmann, who is managing director of Werner Sobeck, a planning office based in Stuttgart, but really present globally. He will explain by the example of Uma Nest, a real-life project built close to Zurich, how future-proof construction works and how it will have to work to make buildings more sustainable in the best sense of the word. But now, Marloes, over to you. I'm looking forward to hear how you envision and build a future of waste-free construction. Marloes, please come on stage.
Thank you, Christoph. I think it's a big task for me to be able to change construction, but we actually have a vision on how we could actually create together a waste-free construction environment. If I am allowed to share my screen, I could start my presentation. Maybe a short introduction about me. I am Marloes Fischer, as introduced by Christoph. I have been born in the Netherlands, been living in Switzerland for the last 13 years, and have initiated my own ventures around creating a circular economy. In Switzerland for 13 years, building bridges to start circular economy by implementing or founding 2 ventures in this area. On the one hand, working on creating awareness, creating capabilities, and helping with the implementation of circular business models. And on the other hand, driving Madaster, the material cataster, in the built environment. And the reason is, why are we talking more and more about the built environment and circular economy? That's mainly because, as Christoph also mentioned, the real estate will annually grow with 1.5 to 2%. A duplication a duplication of the current volumes until 2050 is foreseen. However, our stock of raw materials, which should actually come from planet Earth, is not growing. It's actually reducing because we're taking from it. This is a quote from Thomas Rau, co-founder of Madaster, and also architect who has been working in the built environment for a very long time, trying to push more sustainable and more or closer to nature built environment. Madaster has a clear vision. Material cataster, it's like a place where you document everything that you have in regards to real estate, is necessary because our planet is a closed system. There is no additions to it in terms of resources, and that's why all resources are basically limited editions. The materials that we take, those limited editions, those valuable resources, we, however, treat very easy and create waste out of it as soon as we don't need it anymore. And the thinking behind Madaster is that it only becomes waste because the material doesn't have an identity. So if you would actually be able to subscribe what exactly is it that you have at the end of the lifetime or at the end of your first need, then you would also be able to estimate what the value of it is. And how do you give something an identity? Well, we've tried that with people. We've given them passports. So we apply the same principle, and that is by giving materials a passport. So we have developed a platform for material passports in the built environment that is registering data about all the materials and products that are building the real estate surroundings, and it's been shaped in an online data platform for the built environment. So it basically enables everybody to manage their data around resources in their real estate with a strong focus on governance to ensure security and stability of the data that is coming from it. And that's one of the things that I've taken out of my history of process engineer, is that no data, no action, no data, no commitment, no data, no movement. So we need to make sure that we create a data set around the humongous volume of materials in the built environment, but we also need to do that in a digital environment where there's a strong focus on governance and security to ensure that this is also being used for a societal value. We have identified that this is an interesting activity that you could do on a local level, but it's not so valuable because in the end, borders are set by people and resources are on planet Earth. So we've developed the platform as such that it's available, potentially available on a worldwide level, or it has potential to be available everywhere in the world. We are currently in the Netherlands, in Switzerland on the market and active. And we're working on Germany, Norway and Belgium, that are, especially Norway and Germany, are coming in very soon. And that means that between now and the coming 4 or 5 months. And then Belgium and Austria, I have to say, are being worked on. And we are expecting to be able to announce their more details in the second half of 2021. The platform, however, is actually available in 6 international languages. So when we would have parties interested in other places in the world, then it would definitely be possible to have a conversation about that. So what does it look like? It's a cloud platform with 4 products. First of all, a building dossier, basically all the information regarding materials on a building layer perspective, then a material passport, which is an extract of the building dossier that can be shared with third parties. And then we have two indicators, two KPIs. The one is financial valuation. So what is the value of your resources that you have based on market value, and what is the circularity of your building in terms of how it's constructed and what is the average life cycle. Now, how does it work? The platform actually enables you to upload Excel or BIM files and registers, structures the technical construction data to provide transparency in the materials and products. This is then being enriched by additional sources, additional databases that are available nationally or internationally, with life cycle analysis, with material data, with financial data and toxicity data, that then creates an output of the material passport, circularity indicator, a reuse potential, and a building dossier. This requires, however, a system of a circular economy. Because if you do not, and if you have a platform but you do not have the ecosystem that wants to operate it, that is not really valuable. So we think in ecosystems, and that basically means that we have the capacity for third-party solutions to be connected to the Madaster platform, so they can read information that creates new value, new business potential for third parties. We also have a very strong focus on trusted data, and that means that we work with a foundation by the side, which is chaired by Ken Webster. Hopefully someone you all know, otherwise the first thing you need to Google after this event is Google Ken Webster, a guru in a circular economy, who has basically driven this forward together with Ellen MacArthur on a broader scale. And with this foundation, we ensure that we actually meet societal goals. We talk about societal goals, but we also want to create societal value. That means that we need to facilitate trade of reused materials, and we need to facilitate the process of creating new business out of this new environment that is coming into place, but based on trusted and secure data sources. We are convinced that you can implement structural change only when there is short-term benefit. And that is not because we don't understand that we need to change, but that we humans are relatively limited when it then comes to really making a new step. So we need to propose the immediate benefits at all stages. So the platform is relevant for the full life cycle of a building. You can apply it in the design stage to compare models and identify which approaches actually provide you with better KPIs. You could use it in construction. However, I think there's also a lot of other solutions that are coming up with BIM, where it is maybe the less obvious approach, but you could use it to validate during the construction what impact certain decisions have on your KPIs in regards to financial value and circularity value. You can use it in the use phase by connecting it to your FM systems to make sure that you work on longevity, on repairability, on resource sufficiency, it's called in German, but resource scarce use. And you can use it in the sales phase when you want to show how healthy your building is, especially with ESG requirements. This is a topic that is becoming more and more relevant for the large institutional investors. And then very obvious and something that it is the easiest connection to make. Once you've got everything documented, you know what you can deconstruct and not demolish, what is happening at the moment, so that you actually know exactly what you have for sale. We do all this on the one hand because we want to have a data set that enables us to take better and healthier decisions to avoid waste being created in the built environment on the long term. But we also do this because we want to limit risk. In our built environment, the environment where we are, I think it's about 90% of our time used during the day that we spend indoors. So if we manage to reduce the risk of the construction in that we are operating by making it more healthy, by making it more sustainable in the longer term, we actually will be able to generate value. And we do that by making this information transparent. So why do we need a clear vision? First of all, because it's very easy to be distracted. But second of all, because the resource in using construction are substantially high, and they go much beyond just sand and concrete. Just for example, the single-use plastic is 16%, which comes out of construction. And we relate single-use plastic mostly to straws and takeaway lunch boxes, but actually a very, very large majority of the packaging material is coming out of construction. Then on top, there's a substantial demand for steel, and an increase is expected year on year by 1.1% till 2030. That's not that long to go, which is basically a resource that also has this limited edition stamp on it because it's only so much available. Then in Switzerland, this is different than other places in Europe, but in Switzerland, 84% of all the waste comes out of the construction industry. And in the rest of Europe, it's more about 30 to 40%. Then obviously we have a huge need for sand if we need to double our floor space, and we have a substantial amount of CO2 emission from construction that we also need to change. And we need to change that, first of all, because we want to be able to live on this planet in a healthy way on the longer term. Second of all, because the planet will be there, we might actually have some problems. So how do we ensure that we live in a circular environment, or in an environment that we can stay healthy and we actually can survive? That is by thinking different and by thinking new. And here's an example of Edge, a Dutch developer also active in Germany, who actually has redesigned their headquarters. First of all, planning to actually just demolish the whole building, then coming into contact with the principles of circularity and Madaster, they've decided to reuse the old structure and to create an extra floor or two on top. And then in the middle you see the design, and on the right hand you see the actual building that has been developed. And they have certified, they have reused, they have used modular constructions, they have used cradle-to-cradle certifications. They have basically tried to apply circularity to their building to actually identify what is possible and how they could implement it. And at the same time document everything that they've done. So they now have a material passport for their headquarters and are using this for all their other developments. That's a modern building, but actually circularity is not such a new principle. The principle is very old, and we see that in some of those examples. So what we need to do is find a middle way between high sky rises that are completely modular, but everything new, and very old, super local buildings, for example, the one at the bottom right. I think there's a lot in between that enables circularity, and it's very much about finding a way with documenting to understand what it is that you actually want to do. Set a clear objective and ambition. How do you want to execute circularity? And then use a material passport to measure if you are on track to achieve your goal. So I am now on half of the way, so I want to move forward. I am not looking at any chat, so I will just continue my presentation and show you what Madaster actually looks like. I have used an example of a material passport, of which you will afterwards hear the story from Roland Bechmann, one of the architects from Werner Sobeck, because this is an overview of the Madaster platform, indicating the urban mining and recycling unit in Dübendorf, Switzerland. It's a platform that actually enables you to document everything that you know about your building, and everything you don't know on the longer term you can add. So you could potentially say, okay, I have one reconstruction or renovation of one floor. I only capture one floor, and I do not set the ambition to immediately do everything at the same time. And the urban mining unit is such a case. The urban mining unit is the highlighted central unit that we see in the middle of the picture. And that's the only unit that is being captured in Madaster so far. But it means that there is no, what's the word, rohbouw. There's no basic cement structures that are captured in the overview. And what you see here as well is that you can actually update on the left lower hand side all the average lifetime. A normal building has a lifetime of between 40 to 80 years. This building has an average expected lifespan in this particular unit of 7 years, because the objective of this research center, this vertical village, if you will, is that after 7 years these units will be exchanged, because then they've served their purpose to identify what it's like to live in an urban mining and recycling unit. On the same, at the same page, you could also upload any certifications, if any. You can add any pictures. You can create a connection to the data that you have in your Cataster, and you can see where the building is located. Then on the second page, on the building dossier, you have an overview of all the materials used in the building, and that is being distributed over the different building layers. And the layers of brand is a structure that we've used here. What we've tried to do is always reduce the amount of new things that we develop and use what is out there in the market. And the layers of brand are something that you see back in many reports nowadays when you talk about circularity in construction, because it actually enables you to look at a building as if there are 6 different structures. So you have the site, you've got the structure, you've got the skin, the services / installations, and then the space plan, that's your separation walls, etc., and then the stuff that you have inside. So in this overview, you could see that you have how much material, how much stone, how much glass, how much wood, how much plastics you have in each individual building cycle, which is then visualized based on quantities, weight, and volume. And you could actually reduce this view from a total building to a stock level as well. So there are different perspectives. And then a next layer of detail can be found. So first of all, you know that 99% of the structure is created from wood. When you then click on it, you can actually see that it's the wood actually consists of wooden columns and walls. And you see also the number of walls, you see the cubature, the volume, and you also see the number of pieces that you have. So there's a huge level of detail that you can get to, but you don't necessarily have to have everything. So it's also built up on the principle that a big ambition, small steps forward, and you can start at a level that fits your purpose. Then I've mentioned that we have a circularity indicator, which is based on a life cycle of a building, and it looks at the origin of the material, the use of any potential use of secondary material, and then the reusability and recyclability of the material that you actually use. So when you have 100% new virgin concrete, you have a different value in your circularity index than when you would actually use 100% recycled concrete. And if you use a new plastics or let's say you use a new material for the curtains, you have a different you have a, how do I say that? You have your kitchen layers, your kitchen topping from virgin natural stone, or when you create your kitchen top from recycled glass, you have a different circularity calculation. And what it then does is it enables you to make corrections when you have missing information. So when you don't know what is built in where, and if you don't know which material is used for a particular element, there will be a deduction of the KPI. And this, I think, is something to be very proud of. There's a 96% circularity of the urban mining unit. Be aware it's only this one single unit where you can, which they have achieved, and which they have achieved with very courageous and creative approaches to really find the borders to the level of circularity that can be achieved. We have developed this concept based on existing calculations for KPIs, amongst others the Ellen MacArthur Foundation Material Circularity Indicator. So we've used the same concept, and we've done that in collaboration with BREEAM Netherlands, which is executed or validated, certified by the Dutch Green Building Council, Circular IQ, an organization that is very ahead and advanced in terms of calculating the impact of circularity, and with a few other organizations that work on databases regarding life cycle assessment and footprint calculations. Then we have the financial value of the material that is indicated through the financial index, which is the valuation of the material groups. So we look at the total volume of material that goes in. We then validate that with the market price of the raw material. And then we also provide a nominal value for those who are interested to understand what it would theoretically be worth after that you have actually taken it out. So what are the costs to demolish or to deconstruct? What are the costs to transport this material? What are the costs to prepare it again to be either reused, incinerated, or prepared for landfill? And that then gives you an overview of the value loss, which should actually incentivize the owners to start using different type of construction methods, or to start taking different decisions based on these information, because they would have potentially a value out of a higher residual value of the building. So that was it. That was my story. I now go back to where you are to see what's going on. I stopped sharing my screen, and basically, I think, Christoph, I hand over back to you.
Yes. Thank you, Marloes. But now let's carry on with the program. Roland Bechmann, it's now your turn. We are looking forward to hear you show us your built example, Oma Nest. Marloes already talked about it a little bit, but we're curious to learn more about it, and also what you as Werner Sobeck are doing to make building and construction more circular. Roland, your turn, please.
So, hello everybody. Thank you, Christoph, for introducing me. Thank you everybody at home for joining. I know it's kind of Thursday before a long weekend, so I was quite impressed that no one left so far, so people are coming in. I'm very happy about that. Also, of course, lots of thanks to Barbara for inviting me. So my name is Roland Bechmann. I'm a partner of Werner Sobeck. We are at Werner Sobeck are mainly an engineering office, so I am an engineer, not an architect, quite honestly. And we are consulting basically architects and projects all around the world. And I want to share a little bit one of the very interesting research projects we had, because we also have a small design group doing research projects. And I'm just bringing up my presentation at the same time. And I think I want to talk also about a double challenge. I want to talk also about addressing carbon emissions. So for us, circularity and carbon emissions are basically both linked to the material flow. So we see this kind of as a double challenge a little bit. Just to show you, these are the projects we are typically working on. I don't want to go in them here in detail, but just to let you know, we are really one of the offices really being absolutely in practice as engineers, as designers. And when we build these projects or when we design these projects, we really often have the issues about all the numbers we talked before, and these numbers are slightly lower because I'm using very conservative and different source because I don't want to dramatize, but actually our own calculation show that the numbers for carbon emissions are actually higher than these 35 or 40% we've been hearing before. So the impact of the construction industry on the overall emissions and on the overall resource consumption and on the overall waste generation is really dramatic. And of course, cement actually is one big piece of this equation, is one issue to address in it because it's responsible for about 8% of all emissions worldwide. If we look at the climate goals, we can also make this very fast that even these are the climate goals of the German government, the blue line. The goal is really to minimize all or to put all emissions to zero by 2050. And actually to meet Paris, this has to happen much earlier. Looking at the red line by 2035 would be actually the goal, for example, of Fridays for Future here in this study. At the same time, we still have to keep on building because there's a high demand. Marloes and Christoph were talking about this. And yes, it's sand, but it's also all other resources where we are really running out of supply. So we have to think how to deal with emissions, and we have to think how to deal with resources. And when we are in the demolition phase of a building, we look at these buildings, it's actually very, very difficult to separate all the materials in a clean way. So to have a clean separation of the materials. The demolition companies, actually, they are making a very, very good job. So for me, when I'm on these demolition sites, it's always a wonder how they manage to separate as much as material as they actually do out of this mess. But still, we have to change the way we are designing that this is much better, much simpler, and much more effective because there's still, as we have seen, 50% of all the waste coming from these sites. So we talked about circular buildings. So we have a technical cycle and a biological cycle. I guess you are all aware in this audience of these facts, and we try to borrow the materials only from the cycle and put them back either in a building or in a different use afterwards, and actually try to use materials which have already been used before. So for us, as I said, it's a double challenge: minimizing the emissions and minimizing the resource consumption. Let's just have, and then I'm coming to our project, a short look at how typically the emissions are being generated in a project. So typically you have the construction, and this is what we are calling the embodied emissions, embodied carbon. They are really coming from the materials. Then we have the operation, so we use energy. This is linked to emissions. Then we maybe have a renovation or a refurbishment. Then we have further operation, and in the end we have a demolition. So when we look at these embodied carbon, or in German we say graue Emissionen, and the operational emissions, we really see that the emissions from the materials are just as much or just as high than the ones from the operation. And when we then take into account that actually the non-fossil energy mix is increasing, so that we actually get less emissions from the energy use in the future, hopefully, but also for sure, then we see that actually really the material side of this equation is much more relevant. So the focus on sustainable buildings, only looking at energy, is no longer true anymore. We have to look just as much on the material side. And I think there was a huge mind shift in the last weeks already addressing this. We've been starting more than 20 years ago with a building. We have been following the 000 concept: zero energy, zero emissions, zero waste. That was actually the private building of Werner Sobeck himself. And starting from this, we actually had a story of similar buildings. For example, a modular timber building here in Stuttgart, where Christoph and I are today, that was only a temporary building. It has already it's already moved to a different place, but there we also had a strong focus on generating energy. And then we were invited into this research project. So it's really a project only for research use, the Urban Mining and Recycling Unit in this NEST project of the ETH Zurich. And we are responsible for this middle unit. We did this in cooperation with Dirk Hebel and Felix Heisel. So it was also there from the KIT and Karlsruhe. So it was also really a mix of different researchers and us also coming from the practical side. Very important to mention, I think, there a lot of the credit goes to our project manager, Bernd Köhler, because you will see when we go through the project that this only works with a lot of personal involvement of the design team. Since it was this special configuration, the other units are done by a very good other designers, such as Philip Block, for example, or researchers, I would say. So it's really a mixture of different approaches how to build sustainable buildings. So we had this middle unit, which is kind of pushed into this entire system. And when you now look at the picture, you wonder, why is it looking so funny? Why do we have these different colors? And of course, this portal frame of the facade is a copper frame. And these are sheets from different buildings, most of them from the nearby area. And since they had a different pre-use, we simply took them as they were and put them as the final frame or final cladding on the frame. And we didn't change the color. So this kind of reflects really the way we were collecting the materials for this project. As Marloes was already mentioning, it's a timber structure. So it's solid spruce, actually, we were using, Fichte in German. And we did pre-design this in 7 units. So it was pre-designed and prefabricated in 7 units. And these 7 units were pushed. And when we into our slot within the 2 concrete slabs. And when we design this, we make very sure really that we have a clear idea how are the materials connected to each other. Can we really later on separate them cleanly? And of course, where are the materials coming from? And we make a concept for designing, but also a concept for disassembling it later on. And basically, the methods we are using to select the materials were mainly really reprocessing. So we were, for example, using, like here on the left side of the picture, shredded drinking cartoons as a drywall panel later on. So kind of a method of downcycling. We had the concept of reutilization. So we were one-to-one using either materials or actually elements which had the same pre-life before or pre-use before. For example, as these doorknobs, they were coming from a building in Brussels, actually provided. We didn't collect them ourselves or find them ourselves. There is a company, Rotor, which actually manages a platform where you can find these materials. Or the materials are really 100% compostability, so belong to the biological cycle. For example, like we have the insulation here on the right side of the picture. Very important for us is, of course, also how we connect the materials or how we connect all the elements. We don't want to weld, we don't want to glue, we want to separate them later on. So everything here is screwed, plugged, or clamped. No welding, no gluing. So this is true for the entire process of prefabrication. As I said, we had these 7 prefabricated units in the shop, and they were kind of later on pushed into the location in the building. Here again, you see a little bit the facade or the kind of the mounting of the facade on the right side. So the portal, it's kind of a silver fir we used as facade posts, Weißtanne in German. So that's a kind of a very, very good timber or wood, which can be used untreated. And again, we were not using silicone or anything else to then fix the glass panels on it. We were simply clamping everything with fasteners and pressure bars, holding then the entire facade in place. Also, what you notice, of course, we merged the facade line with the column line so that we had no interior columns. And on the left side of the picture, you see that this is also true for the entire technical system of the building, which was actually the most or the biggest challenge, because there we were in a field which is not regulated at all. This is a look from the interior. The entire interior finishes are, of course, extremely important in the circular buildings. So we had kind of these ash flashboards. We had even the furniture was selected according to the principles, circular principles. The facade glazing, for example, we didn't use any coating or anything as we would do maybe in other projects. So this was really untreated. Of course, we were then using textile sunshades out of recycled fabric. Here, another picture from the interior, a concept which you sometimes hear in other projects as well, that we didn't buy the carpet, so it's carpet laid loose, not clamped, not glued, and you can simply rent it, for example. And of course, you can create more or less the exact same product out of this again. So it's only a leased carpet. When we look at the interior walls, for example, we tried also different methods. All of them have actually a loam plaster to cover it, but we actually did not cover some of the areas so that you can actually see it. And what you see at the very right corner is something which came from our colleagues from Karlsruhe. They were actually experimenting with a type of mushroom. So this is kind of a drywall board made out of a dead species of mushroom. So it's not living anymore. It was heated to 60 degrees, but it's actually really a biological component we are using. And of course, with a certain mixture with other biological aspects. Then for other materials or other walls, we were using, for example, this dried or heated drinking cartons, also as a reuse, maybe a real reuse of waste products within the unit. And as I said, a lot of attention, especially from our project manager, Bernd, went to how can we construct the entire technical system, the MEP system, without using products which don't fit into our concept of circular material flow and which can be separated really into pieces. And this is, for example, an interesting point for a discussion. You are clearly out of the typical range of warranties in projects. So we only could do this here because, of course, it was a research building and the client accepted that we are, in the end, giving him products which don't have really a product certification for this use, because it was, in a way, handmade for this project. So the sprinkler system of untreated steel, fresh water pipes out of pure copper, for example. So really something where we were looking into all the materials. Of course, we had different materials. Some of them are actually very well-established materials from products you can buy on the market. For example, like this glass ceramics from Magna. This is also reused glass. It's only melted to, again, I think about 100 degrees or so. So you even see the different pieces of the glass. It's just melting a little bit. It has a surface polished finish, or, for example, these sheets, staple sheets, which are actually reused chopping boards and, for example, kitchen work surfaces. So also really a material that you can buy on the market, but which is reused, 100% recyclable. For other interior walls, we were using a waste brick wall. And there we didn't use any mortar to connect the bricks. So they were only stuck onto each other, as you can see it maybe there in the picture, or here really from the production or from the erection of the building. So no mortar to put this into place. They are simply stuck on each other, but at the same time, of course, provide more or less the same noise reduction as a regular wall, interior wall would provide. Here, another picture, kind of how they were fixed to each other. And again, no mortar, nothing glued, simply clamped and stuck. But this was true actually for every element within the unit. So for example, for this heating and cooling panels, they were developed together with a company here from Germany. But again, they are simply made out of aluminum, the panels, and everything was only screwed, nothing was glued and clamped to each other. So this was really specifically designed only for this unit. So we had really a variety of different materials, from denims, from mushrooms, from hemp, from loam. We used the chopping decks. We had different types of timber. Of course, we were using mineral wool, we were using paper, but everything can be separated really back to what it was as an origin and can be used again. And actually, this will happen in this building maybe pretty soon, because it's only there for 7 years, and we will see how the materials can be reused. So our hope would, of course, be that we would get a chance to reconstruct a totally different building exactly with the same materials in about 7 years. So let's see if this maybe dream comes true. When we design projects, of course, in BIM, we think you can already make your material passport for your project in BIM. I think that then makes it easier and simpler to convert it to Madaster, as Marloes was saying. If, for example, your client is not already connected to Madaster, we try to do this for every project. In our BIM models, of course, we provide also all the information about the materials, about maybe also the certifications for the materials, the EPDs. But of course, unless it's connected to a database, no one knows out of it. No one knows about it, and you don't get a feedback on the costs. I think what is the real challenge for us is to how can we bring these principles into the real life of our project? So can we really take this and build residential buildings? For example, this is a residential building we realized actually even at the same, more or less at the same time as we were designing this UMA unit. And of course, we were using many principles of how we connect elements also in these units. Of course, it's a little bit different because, as I'd said, in some parts you can really, you're meeting really the boundaries of typical warranties. And of course, you cannot develop too many unique elements for every client, because in the end, the special development of, for example, some building elements is actually a small risk. And of course, it has financial aspects related to it. Why are we using so much timber? Of course, because it's coming from the biological cycle, but of course also it's because it's really during the lifetime of the timber a storage for carbon. So we see timber really as one major part of reducing carbon emissions from the construction industry. So we are very convinced that more timber structures are necessary. However, concrete, we cannot really stop building our buildings in concrete. Some of them will only work in concrete due to different conditions. Plus, we have to see that it's impossible that there's also a limit to how many timber buildings we can build. Again, concrete has not only the problem of energy, it really has the problem of the chemical equation for cement, sorry. So that this is actually kind of that the carbon emissions are actually coming really from this chemical process during the cement production. So this is why we believe in these terms, we really have to minimize simply the constructions due to typical or even very unique lightweight methods. Marloes already talked about recycled concrete. We believe that this is also an important part, especially on the resource side of it, because we are mainly saving resources with this. So something between 25 and 40% of the overall concrete mix will be used actually, or will be replaced with used concrete. So basically the gravel. But of course, since we still have new cement in this recycled concrete, this does help to address the resource problem, but only addresses this emission issue to a certain extent. But it's an important part. Depending really where you are taking this concrete from or using this recycled concrete from, is a site where you're taking kind of a building down near to your construction site. This does have an impact on the costs, but also on the emissions. So when we design, for example, a recycled concrete project, we make a material mapping ahead of time. We actually research where are projects, where are construction sites with the demolition going on, will they bring their material to a demolition company, and can we use it afterwards? So also this goes really into checking the material flow. Actually, a good question for the Slido would have been, what do you think? How much of your reinforcement bars, of your rebars in a concrete structure is actually recycled? The interesting answer, it's about 99 to 100%. So all the steel in your buildings, all the rebar steel at least, and almost also the other structural steel are reused airplanes, reused cars, because of course the way we are using steel in the construction industry is kind of the lowest quality you can do for steel compared to other qualities. So the emissions in the steel industry are actually coming really from the steel mill and the rolling mill, and there is mainly the goal to actually change or reduce the energy mix. So our idea is to really have a zero waste design, to have a zero resource design, but also a zero emission design. And for that, we think actually all designers need to track resources and emissions at least with the same power as they typically track costs for their clients today. So this is something where we are strongly convinced that this only will improve if we are aware in every construction how many resources are we using, how many emissions or how much emissions are we actually emitting with our structures. And then in the end, of course, you can come to structures where you don't have any, which are actually net zero structures or buildings, even if they are made out of concrete and not out of timber. So you can generate energy during the operation by photovoltaic, for example. You can drastically minimize the emissions from the construction, especially when you're using circular materials, when you're following the principles of a circular building, because all the materials you are reusing, you're not only taking them away from nature, you're also not investing any energy or emissions to manufacture them in the first place. You have a decent or still a remaining portions of emission coming sometimes from, of course, reconfiguring these materials, of changing their shape. But after all, the big solution really to address resource consumption and to address emissions is using more circular materials. Maybe not every project has to be as radical as a Nest or a Yuma unit here, but of course we are looking for ways to implement this really into our day-to-day design life. We can only make a change if we really apply this to the mass production of our products. Yeah, thank you. I hope you did enjoy the slides. It's always a little bit difficult when you talk only to the monitor and don't see the audience. But at least I'm quite happy that no one left during my talk. So I hope that you did actually find something interesting.
I certainly very much enjoyed, Roland. Thank you very much for the contribution. So I'd invite maybe Christoph to join and Marloes as well to come back. for the open discussion, where we will also involve our audience. So if you want to come on stage and have a question, I will be sharing the Slido. Upvote the questions that you think are interesting, and we'll get the discussion going in this manner. So yeah, so Christoph, up to you.
Before we start into opening it into the discussion, I would like to ask you, Marloes, can you join? Because I would like to ask you both, Marloes and Roland. You were talking very much about, let's say, the future of buildings and construction. Even though you showed us an actually existing project, Roland and Marloes, you also gave us a glimpse into your database, but we're not there yet. So I would be interested to understand or to have a comment from your side. What do you think are the main impediments or the main obstacles that we are not there yet, and what has to be overcome as the main obstacle? Roland, as long as Marloes is not here yet.
Yeah, I hope Marloes will be joining, but in at least my day-to-day life as a designer, it's really difficult that you cannot control the entire process, that no one can control the entire process. So as a designer, you start somehow, then you have a tender, you have a bidding process. And of course, this is actually good because you have many actors collaborating, but at the same time, it's not like in the construction industry, we are almost not like in a position like the car industry that we say, okay, we now radically change it, because we always have to rely on that someone else is following us after. And I think this makes it more difficult, but actually constructing or designing is really, really complicated. I think much more complicated than we sometimes think. So I think we are on a good way there, but this is for me the main challenge, to bring all parties together. And we need, of course, knowledge for that.
Thank you. So Marloes is still not here. Marloes, if you can hear us, please try to join again the stage. We would like to see you back. And I have a look on the questions now. So there are quite a few questions coming in or have come in. I see Peter Moonen, who asked the question. Maybe you want to come on stage yourself and ask your question. Otherwise, I can also read it out loud. But Peter, if you're there, it doesn't hurt. So just come up on stage. There's a button on the top right where you can join, hear us on the stage. I see Peter joining. Yes, Peter, please go ahead.
Yes, one of the things, I'm in Vancouver, British Columbia. Thank you to Barbara for inviting me to attend this. It was very interesting. One of the things that we face, given the buildings themselves, the structural components are a huge impact. All too often, buildings are fused or welded or cured together. And being in the wood industry, a lot of our stuff is mechanically connected. But how do we design buildings that we can recover the function, not just the material itself, but buildings that can be reused or moved, whether it's modular, whether it's components or what have you? Because that's very difficult when you have seismic issues and structural issues, and it's one of the difficulties with buildings that could last a long time but don't. So we should really try to recover that function, and at the end, if we can no longer recover the function, then we can recover materials. But designing for longevity and designing for disassembly are a challenge, and it also challenges our ego. We like to see something new, something different. So we have, as human beings, have to make a decision, or a conscious decision, that we're going to keep these buildings and we're going to reuse them. But how do we design them? What are the methodologies that you've uncovered that will allow a variety of different buildings to be reassembled or deconstructed and reassembled? Thank you.
Who wants to go first? Marloes? Any hints?
Well, when you talk about the design, I think Roland is in a better place to address that question. I do think, however, that, you know, when everything would be clear on how we would do this, a lot of these kind of constructions would have been made. So it's, you know, it is a trial and error, and I love the examples of the urban mining unit, because it just indicates that there's a lot of innovation on the way, and there's also a lot of regulations that need to be made, reviewed, to be able to also use lightweight and to use new materials and products, in regard, for example, to fire protection, etc., because they're all based on the assumption that all materials are new. So, Roland, I mean, that's my non-architectural engineering answer. How would you build to make sure that this is all being reused? I think you gave examples, but...
Well, first of all, Peter, I must say that I agree to 100%. Actually, I couldn't put it in better words. So we were simply focusing on the circularity. I think most important is also that buildings are, in the first place, flexible for different kind of usages, so that, for example, if the client changes the way he is working in an office environment in 10 years, that your building is flexible enough to allow for this, so that you don't have to make this large renovations. Then second, of course, you can take entire building elements and rebuild them, and maybe reconfigure even a new different building out of them, with this mindset of modularity. So I was showing this one modular timber unit that moved as a whole to a different location after being at one place for 3 years. But you can think, of course, also of a system where you have slabs and so on, which can be reused in a different configuration. Why doesn't this happen? I think basically because there is no industry. You have one client building one building, and he hardly ever will be in the position to reuse it again. And plus, so far, the buildings are not designed for it. But I totally agree. If I would be the rich client of a new office building, I would design it exactly in this manner today, knowing this. And of course, going into the details, how we do that, we have to meet and design. It won't be easy, but I'm convinced that we could do it.
Marloes, I was asking, I think you heard it at the start of our discussion, for impediments or obstacles, and what from your point of view is the biggest obstacle why we are not further ahead in advancing circular buildings today. Can you comment on that, please? You're still muted, Marloes.
I was in a technical stress and it's not resolved. Apologies. What are the biggest what is the biggest obstacle? I think the missing collaboration across the supply chain. It's very much thinking about, you know, who are the users, who are the reusers, who are doing the maintenance at the very early stage, and the collaboration that is currently broken, I think, is a critical requirement in order to define also the type of constructions required for the longer term. And in addition, I think it's also a little bit of our personal, it is a lot of change aspects that are required. And Roland mentioned it before, there's a lot of collaboration needed. There's a lot of asking questions and getting involved with different stakeholders that you usually wouldn't. And this morning I spoke to a big producer of raw materials, and he said, you know, we know our customers, but we don't know the users. So we need to get in touch with the network across the full value chain in order to be able to understand what potential solutions are. And I think that's one of the things that, you know, we try to realize with Madaster, which is in the end just a library where you document everything, but it is a way to make sure that you create visibility for all stakeholders across the value chain, so that all the fantastic and valuable materials that are created during the design and construction phase are also being used afterwards during the use phase, during the deconstruction phase and the reuse phase. And I think the tools, technical tools for design and construction are there, what we have seen is that the managerial tools to actually use this data to the benefit of society and the benefit of economy are not so broadly available, and that's how we came up with the Madaster platform.
Thank you. I look back at the questions. I think we have one that is more or less answered. See, circular economy in buildings is an excellent approach, but how and how fast can this be implemented in the daily work of construction companies doing business as usual? I don't know if you have any further aspects to add to that. Otherwise, I would say there's another question coming up now, being higher rated.
I think it's a super cool question, actually.
Go ahead, Marloes.
Yeah, I'm sorry,
Please.
because I think,
Sure.
I think I mentioned it before. When you start applying principles of circularity, or when you start applying common sense architecture, I don't know which one it is, because it's like in that sense not new. And as Roland mentioned, it's something that they've already been doing for a very long time. I think it's very important to set yourself ambitious targets, but to start taking small steps towards, what it could be. And I mean, the one is starting maybe with defining how you want to position yourself in a circular world. Is that on on a broader level where you want to use the resource, the human resource? Because I think it's something that often gets forgotten, that circularity is not just about material loops. Circular economy is about society, it's about environment, and it's also about an economy that actually functions well. So positioning your idea and creating a strategy around it, and then taking small steps towards this, which is, for me, a normal management principle that you should apply.
Yeah, maybe if I add one thing, how can we really make sure, or why are we not building more in a circular way? I think what you really need are ambitions, but I think many designers have them. But in the end, it's also really about economics and regulation. So I'm pretty convinced that as long as the economics behind it and the regulations don't get adjusted at least slightly. So I'm really talking here about a price factor on emissions and on resource, taking away resources from the earth, kind of. If you don't get a price for that in your day-to-day business, there won't be a global change. So I think it's nothing designers can tackle by themselves without political decisions as at least a support for this.
I think, and I also completely agree that it shouldn't be the designers who are going to change everything. I just think it's also, at least in my day-to-day practice, I realize that regulation or missing regulation is often used as an argument to not do anything. And that's why I think that collaboration across the value chain is so critical. And because at the same time, the owners need to start ordering circularity, or they need to start requesting the principles. Because if that doesn't happen, the designers cannot start to plan it, because they're not sitting on the business case. So it's I love the idea of a financial incentive for CO2 and resource use. I think that's absolutely the future. I'm not sure if we can wait until then because that's like a systemic change which is taking us too long. So therefore, I say, start with taking small steps forward.
You both here today have presented projects that have started the future without waiting for everything being in place. Yeah, so you're the best examples of what you just said, Marloes. It's getting now more and more ambitious on the question side, and I would really just read out a couple of more questions to gain some time. There's one question that really refers to a concrete, wants to know, where do you find marketplaces or platforms where you can get the material? Roland, you mentioned Rotor in Belgium. Are there any other places and platforms you're aware of where you can find those materials? Short question, short answer, please.
Short answer is it's, as Marloes said, the entire supply chain. So some of them were brought in by the researchers, Dirk Hebel and Felix Heisel, some ideas. Some of them were brought in then actually by the construction companies involved, like that was a timber construction company, Kaufmann. They had ideas from other sites, basically, and a lot of research of our project manager, basically also on demolition sites, really looking what is there, what can we use. So you cannot buy it actually in a book or on a shelf. You really have to look for it at this point of time.
But I think you definitely need to look. What we see happening though is that a lot of marketplaces are coming into place, and it depends which country you are. In Germany, there's Restado that is now really making a move, which I think is really cool. Also applying digital technology to make it to a larger scale available. In Switzerland, we've got a lot of these local, Bauteilbörse, as they call it. It's not enough to actually supply architects and engineers all over the world, but a key thing is that you have a local source. And it is something in the Netherlands. There's a platform. It's called Insert. You've got Access Material Exchange. You've got the Harvest Map. So I think it's cool that we start seeing those initiatives. What needs to happen, which is one of the visions that we have with Madaster, is that through this connection of a third-party solution, you could potentially say, okay, this building is going to be deconstructed. So, for example, the urban mining unit has 7 years to live. That's the plan. I think it's been February 2018. It was actually put into action. So that means that in 2025, 26, they will basically, or 24, or 26, they will demolish. So as the urban mining unit is not demolished, deconstruct and reuse, apologize. All elements and products are registered. So our vision is that there is going to be a party providing a solution that says, okay, we've got a marketplace based on a virtual material depot. So the material in the urban mining unit can be registered like a tick box saying this is becoming free in 3 years. Then architects and designers can start to work with this as a source for their plans. That's the future, but obviously a virtual depot is still very far away of reality. Plus all the needs to refurbish or to maintain or create or clean up. I mean, that's there. So I think you don't get away from, like in between inventory management, which is also a bit of a challenge still to take that into account. But an interesting business model potentially. We don't hear you.
Don't hear me?
Now it works.
Okay, sorry. Let me just add a question that comes from Anna de Zogus, who asks, has there already been one project really realized with Madaster where the material of one building became the source, the resource for another building or for other buildings?
Yes, actually. And wasn't a new building, and that I think is something that it's a question that we get a lot. What happens with in German, what they call the Bestand, the existing stock of buildings that we have at the moment. So what we have done several times already is actually taking stock of all the materials that are within a building that is planned for demolition or deconstruction. And then separating the resources and the product, so that what is raw material or what needs to go back to become raw material, like concrete, and that what actually can be reused on a product level. And this was a case, a concrete case in the Netherlands that they've actually used also to engage with their community and to provide a lot of the interior materials, so the sanitary construction, the kitchen, the walls, the closets, etc., that have been kind of been reused in a close neighborhood. And we are seeing in Switzerland that more and more locations are starting to ask for a registration of the building stock, because it will facilitate them with the renovation of buildings. So then they start documenting, and piece by piece will basically either remove it or reuse it.
Mm-hmm. Thank you. Before we come to a close and the closing words from each of us and each of you, Roland, there's another question for Nest, and which goes to you. Somebody wants to know, what were the biggest challenges in planning and construction? I mean, some were already illustrated by you during your contribution, but what were the biggest challenges? And another aspect of it, is there something you would do differently today with all the knowledge you have now?
Let me answer the second part first. I'm sure there is, but we are absolutely happy as it is. If we would redesign it today, it would, I guess, look totally different. But I wouldn't see anything like a mistake or so we would redo. The second thing, the challenge is really bringing the entire supply chain together, developing new materials or developing configurations of materials, and that was only achieved, for example, because we had such a dedicated team, especially, as I said, Bernd, who was calling people and bringing them together. I think that was the key. That's how it's possible.
I have the question from Marcus here. So how is it with the possibility to connect your material database to a BIM position? So this integration aspect of the material layers in the BIM position.
I guess that's a question for Madaster, for me, right?
Yeah, I think both of you mentioned BIM, so I think you can have, yeah.
Please. So I think digital construction is the future. It is not reality in all places, but it's definitely something that will be getting towards. So BIM is for us basically a foundation from the conceptual perspective. So everything that has been created in BIM could be read into Madaster, and if it meets certain basic guidelines from the Building Smart International structures that are available, then you would actually be able to upload a material passport without too much trouble. We do, however, see that BIM is by now not yet used everywhere, and there's a lot of parties that have difficulties, and that's why we also offer the possibility to upload the materialization in a simple Excel format. But obviously, the complexity of a building is as such that manual registration is quite cumbersome, and I think Felix Heisel, who has actually written his PhD around this topic, has spent quite some time in the documentation. But on the other hand, we also see that for buildings that get certification, a lot of the material is anyway documented in the volume and with a lot of details around it. So if you could use this material listing for Madaster, it's absolutely not a problem, and we've also done that already in the past.
Yeah. Roland, anything else to add?
No, I think that this is how it works. I cannot add much. I mean, we try to have all information we have as designers in our BIM models. Sometimes we don't know what for, but I think the future we will use it and reuse it again.
Mm-hmm. Okay, a couple of more questions, but I think to not overstretch the time frame too much, I would like to come to a closing. And maybe before you give your closing words, Marloes and Roland, I would like just to say what stuck with me from your contributions. And this is really the fact that you both stressed, like you were both putting in front of us the idea of a library, living on a limited, finite earth where materials, Marloes, you said, where all resources are limited editions, which I like very much. And Roland, you said we borrow them. This is a library. That's really an approach. I mean, everybody knows the concept of a library. We go in, we take things out, we keep them for a little while, and then we give them back. But that's not the way how we look at our life and what we do in life usually. So that's really a very, very impressive image. And the interesting thing was that you both brought it up today in an aspect where usually you don't see that. Buildings are constructed once in a lifetime, then you live in it, and then you give it on to the next generation, but without really thinking about this library approach, which for me is really something that to take away from tonight. And Marloes, Roland, I would like to ask you to give the closing remarks for tonight from your side.
Okay, I leave the final remark for Marloes, so I start. Well, I'm in Stuttgart now for 20 years, and when I came, I walked down the main street, the Königstraße, and when I walk it down now, 20 years later, it really looks totally different. So buildings have changed, our cities constantly change. It's not like they are so permanent. Even in a short time of 20 years, cities entirely change their face, and we have to kind of consider this in our design, minimize our resource consumption, minimize our emissions, and do that all together as designers, investors, database organizers, and of course also consumers and people living in and working in these buildings.
Lovely, Roland, because everybody says we build forever, our buildings are for indefinite times or 100 years, but I don't know how many heard of buildings that are demolished because, it doesn't fit our needs anymore. And our needs will change faster than at the moment. So I think what we need to do is a closing comment, maybe a little bit of philosophical one, but when we leave a hotel room, we always look back to see if we have left it behind us in a state that represents our morale, our perspective. When we leave this planet, which for sure is going to happen, I mean, there's nobody on this planet who's not going to leave it, right? We should be able to look back and say, we've not left any mess behind. And in the end, that's what we are doing. So taking consideration of the impact of our behavior and the consequence of our behavior, I think is going to be a critical thing. And it requires a lot of brave and brave minds and courageous creatives to come up with a better solution that enables us to live on this place, on this planet.